Hello everyone and welcome back. I'm Mr. Cobalt, and today in this video I'm going to continue to talk about molecular, ionic, and net ionic equations, but I'm going to do a couple of problems. So in this problem, problem 1 and 2, both problems you're given a molecular equation, it's balanced, and you are asked to provide both the complete ionic equation and the net ionic equation. So let's start with problem number 1. So with problem number 1, they give you everything. To get the the complete ionic equation, you are simply going to separate the ions or separate the substances into their separate ions, and except for the solid. So the solid, though, that's going to stay together. But anything that's aqueous, you're going to separate. So let's go ahead and start here. So if you have a coefficient, that's going to carry over to both ions. So that 3 is going to be 3Sr, and that's a 2 plus aqueous, and then plus, and then you're going to have 3. Now this subscript is not going to be there because you have 2 chloride ions. You're not going to write this. This is not what you're going to write because the chloride ions don't exist together as a diatomic molecule. That is gaseous chlorine. But we have chloride ions here. These are going to be separate. So you have 3 here and you have 2 here. So 3 times 2 is 6. So you have 6 chloride ions. So you're going to put a 6 there. So that's your coefficient 6. And you have chloride, and it's aqueous. So that's how that works. Okay, so we're done with this one. And now we're going to do this one. So we have 3, or we have a coefficient 2, but we have 3 lithium ions here. So again, lithium ions are not going to be together. We're not going to write lithium 3, right? That's not how we write it. So these lithium ions are going to be separated. We have 2 of these, so that means we have 2 times 3. We have a total of 6 lithium ions. So we got to write 6 Li plus, and that's aqueous. And we have 2 phosphates. So that's going to be 2. And we have PO4, 3 minus, and that's going to be aqueous. So now we just separated the ions for the reactants. So now we're going to do the products. So we have this as a solid, so this is going to stay together. We're not going to separate the solid. So that's going to stay at SR3, PO4, 2, and that's solid. And then we're going to separate these. So here we have 6 coefficient. So 6 lithium, that's going to apply to lithium. So plus 6 lithium plus aqueous plus, and then we have 6 chloride ions aqueous. So I'll write that down here. 6 chloride minus aqueous. And so that is our complete ionic equation. So everything is separated into the ions. We still have the same number of ions as we do up here, except they're written as coefficients because, again, the subscripts indicate how many of the ions we have, but we're not going to, if they're separated, then they're not going to stay together like that. Okay, so that's why everything is in the coefficients. Okay, so now that we have our complete ionic equation, that's part of the problem. So the second part is to write the net ionic equation. And that's where you have to identify your spectator ions. And again, the easy way to identify the ions that are not spectators are the ones that are making up the solid or liquid or gas, right? So here we have a solid. So the strontium and the phosphate, those are the players. They're not spectators. So the rest of them are going to be spectators. And you can identify the spectators by the fact that they stay the same on both sides. So you have strontium here, that's a player. You have 6 chloride ions aqueous, and you have 6 chloride ions aqueous. So they're not doing anything. They are floating in solution before, and they're floating in solution after. So this is going to be a spectator ion. So these are spectator ions. And you have 6 lithium aqueous, and you have 6 lithium aqueous. So they're floating around before and after, so they're not doing anything. They're just spectating. So those are going to be your spectator ions. And so what's left over are the 2 players that are in your reaction. So we're going to eliminate the spectator ions, take those out, and then whatever's left is in the net ionic equation. So that's going to be 3Sr2 plus aqueous plus 2PO4, 3 minus aqueous, and then that's going to go together to form your Sr3PO4 2 solid. And so that is your net ionic equation. Okay, so that's the first problem. What about the second problem? So same thing. Here we have an acid-base neutralization problem. So the acid-base neutralization problem is basically you're taking an acid and it's going to react with a base, and you form liquid water and you have an aqueous salt. So first thing we need to do is write out our complete ionic equation. So once again, anything that's aqueous, we're separating the ions. So in this case, since this is an acid, the first hydrogen in your that represents the acid is an acidic proton. So that's going to come off. That's going to ionize. So you're going to get H plus aqueous, right? And we only have 1, so that's going to be just 1 there. And then you have the rest of this is going to be your anion. So C2H3O2 minus aqueous. So that's going to be your polyatomic ion. This is your acetate ion. And then, so that's done for that one. And then we have KOH. So that's aqueous. So the metal is your potassium. That's going to be aqueous, and that's going to be separated from your OH. We have 1 of those. So that's your polyatomic ion, H minus, OH minus, and that's aqueous. So now we're done with our 2 reactants, our acid and base. And so now we're going to do our products. So water here is one of the products, and it's liquid. So, and it's not aqueous. So if it's not aqueous, then it is a product. It's something that was formed. So we went from aqueous to aqueous right here. So we have 2 aqueous to something that's not aqueous. It's not a solid, it's not a precipitate, but it is a liquid. And so it was formed. That is a product. So we're going to keep this together. It's not ions. So it's still H2O. So liquid. And then here we have aqueous. That is an salt, an ionic substance. So that's going to be K plus aqueous plus the acetate ion, C2H3O2 aqueous. And so here we have our complete ionic equation once again. And then next we have to identify the spectator ions and remove them. So once again, we look at what product was formed, and whatever is formed in this product is part of the reaction. Well, what is going to go together to form water? Well, that's going to be your OH and your H plus. Your OH minus and your H plus go together to form the water. So if we look at this one, we have acetate ion aqueous, and we still have acetate ion aqueous. So that is a spectator. So there's no change here, no difference. Here we have potassium aqueous, and here we have potassium aqueous, no change. And then here we have these two have disappeared and formed water. So we get rid of these guys because they're spectators. And so the net ionic equation is going to be H plus aqueous plus OH minus aqueous, and that's going to form H2O liquid. And so this is our reaction. So this is the net ionic equation that forms water. Now, one of the things I want to mention is that there are going to be times where, like I said before, where you're not going to get a product, right? So if you have aqueous on this side and everything, all your products are aqueous, then basically there's no reaction going on. So all your ions would be separated into, all your ionic compounds would be separated into ions. All the aqueous would separate into ions. And so everything would be a spectator ion. So in that case, there's no reaction because there's no players, there's nothing coming together to form anything. So in that case, there would be no net ionic equation. So you just have a complete ionic equation, molecular equation, and but there would be no net ionic equation if there's no reaction. Okay, I hope this was helpful. I hope the problems helped. And if you like this video, please share the video, like the video, subscribe to my channel, and make a comment in the comment section and let me know what you think. And hit the notification bell so you can be notified by any videos that I put out. Thanks for joining me, and have a good night, and see you tomorrow.